Hey there. So I told you we were going to do 3 problems. We essentially got to 1 or 2 or 3, depending on how long you stayed in class. But here we go. So these equations are exponential. The first thing I want to mention is that you don't have to check for extraneous solutions because exponential equations, an exponential accepts any input value, positive, negative, weird, irrational, rational, nice and neat. So I won't have to check for extraneous solutions. The next thing is that this looks like a quadratic equation. If you let u, or whatever dummy letter you choose, be the variable portion of the middle term, then u squared is e to the x squared. Power to a power means multiply your exponents. Then I can rewrite my equation as u squared minus 14u plus 40 equals 0. This factors using good old AC method. And I'm thinking it's minus 10 minus 4, so u squared minus 4u minus 10u is minus 14u plus 40. U equals 10, u equals 4. Going back to my exponential, I've got e to the x equals 10, e to the x equals 4. So now I've got 2 options. I can either rewrite this in logarithmic form. If I do that, I'm going to say, well, log base c of 10 equals x, more commonly known as x equals ln 10. Now, if you don't want to rewrite in exponential form, remember you could take logs of both sides. The opposite of e to the is ln of. So ln of the left equals ln of the right. Ln of e to the x isolates x, and that's equal to ln 4. Okay? So that's one of your 3 equations. Let me mention on this one that if you want to go without dummy letter, you can. So if you just want to know that e to the 2x means e to the x times e to the x, and you factor it AC style right here, hey, that's okay. Because first is e to the x times e to the x, which is e to the 2x. Outer is minus 10 e to the x. Inner is minus 4 e to the x. So if I added those, I would get minus 14 e to the x. Last is plus 40. So there is absolutely nothing wrong with dispensing with the dummy letter. And doing it without a dummy letter. That's fine, okay? This is the same type of equation. Again, I'm going to let u be the variable portion on the middle, so 8 to the x, meaning that u squared will be 8 to the x quantity squared, which is 8 to the 2x. That means 8 to the 2x is u squared, minus 6 times 8 to the x is minus 6u plus 8. I can again AC factor. So I'm thinking u minus 2, u minus 4, u squared minus 4u minus 2u is minus 6u plus 8. So u is 2 and u is 4. Now u equals 2 can be replaced with 8 to the x equals 2, and similarly 8 to the x equals 4. So whenever I say u is 2, u is 4, it makes me think of the movie The Help, where the lady tells the little girl, you is kind, you is smart, you is beautiful. So there, u is 2, u is 4, and u is smart, right? Now on these, I can do logarithms of both sides, but I can revert back to exponential equations type 1, where both sides are powers of the same base. So 2 to the 3x equals 2 to the first. You see what I'm doing? And then x equals 1/3. Likewise, 2 to the 3x equals 2 squared. 2 squared. I said squared and wrote x. Yeah. So x equals 2/3. You is smart. Me is not doing so well there. So sorry about that. So the last equation is the one that I've written a little bit weird. Now here, if you let u be the middle term as it's currently written, then u squared is going to be 3 to the 2x plus 2. But that's not what I've got there. That's not what I want. The middle term needs to just be 3 to the x. Well, what do? So you all know that, like, if I've got ln of x plus ln of 5, I condense by making it ln of 5x. So I go from separate logarithms to condensed logarithms, add to multiply. Well, remember, with exponentials, if you have separate exponentials, then you condense by adding exponents. So I've gone from separate exponentials condensed to a single exponential, from multiply to add. That's what I'm going to work with here, except instead of condensing, I'm going to go backward and expand. So I'm going to say, oh, decompose this into two separate exponentials. And then 3 to the x times 3. Let me write that as 3 times 3 to the x. Now I can say u is 3 to the x. U squared, well, I didn't need to write that, is 3 to the x squared is 3 to the 2x. There's no need for me to have those parentheses there. Now I can say 3 to the 2x is u squared. This 3 times 3 to the x would be 3 times u minus 40. Is it minus 40? Yeah, equals 0. I'm double checking my notes. So this is also going to factor. So it looks like it'd be u plus 8u minus 5. U squared minus 5u plus 8u is plus 3u minus 40. So this one's got one added twist that I wanted to address with you. So u, remember, is 3 to the x. Now here, remember, you can either rewrite this in a logarithmic form. So it'd be log base 3 of 5 equals x. So I'm going to switch places. Similarly, I could rewrite this in logarithmic form, or I could take logs of both sides. The opposite of 3 to the is log base 3 of. So log base 3 of 3 to the x equals log base 3 of negative 8. But wait, this says that x equals log base 3 of negative 8. And you must only take logs of positive input values. I can't do the log of a negative input or the log of 0. So this is just no, that's it's not an answer, okay? So you only get one answer here. The second answer isn't extraneous. The second answer just isn't defined. So one answer only, and that, and that, and that's all, folks.